Alright, in this video we're going to do some mixed practice, which means there's some ionic, there's molecular, there's acids all together. So we really have to sort these out. So the first one I look at, I see copper. I know that's a metal, and bromine's a non-metal. So this tells me this is ionic. So I'm going to follow ionic rules, which means there's no prefixes. So I divide it in half. Copper, Cu is copper, and Br is bromide. There's absolutely no prefixes because it's ionic. However, I then remember copper is a transition element. It can form multiple charges. I have to investigate, figure out what charge of copper is. So it's CuBr2. So I figure out bromine's charge is -1. So copper's must be +2 to balance it. So this is copper 2 bromide. All right, next I look, P is a nonmetal. F is a nonmetal, so that means this is molecular. So this will use prefixes. So this is going to be phosphorus. I don't say mono because it's listed first. I don't need to use mono. And then trifluoride, tri for 3, and that's it. This next one has H in the front, so that's usually a sign of an acid. It's only 2 types of elements, so it's a binary acid. So binary acids are hydro, and it's iodine, so it becomes iodic acid. That's that. Next, I have a nonmetal N and another nonmetal Cl, so this is molecular, uses prefixes, so dinitrogen. And then 7 is hepta, and then again, always change my ending to ide, so heptachloride. This next one's ionic because it has a metal and a group of polyatomic ions, so this is going to be iron is Fe. SO4 I recognize as sulfate, but once again I say iron's a transition element, could have multiple charges, so I can figure it out. There's 2 Fe's versus 3 SO4's. Each SO4 is -2, adding up to -6. So each iron has to be +3 to counter that. So this is iron 3 sulfate. Lastly, this one is an acid. Again, it's got H in the front of it. That's usually a sign. CO3 I recognize as carbonate. This is not a binary acid, so they say this is carbonic acid. I just changed the 8 to ic, and that's the convention. So with mixed practice, you really might want to take the steps and write out what set of rules you're following. Are you ionic, molecular, or are you acid? Because you really have to follow different sets of rules for each. Here, it's a little easier because if there's prefixes, you're going to use them. So right away, dinitrogen tetroxide, I can say nitrogen and oxygen are both nonmetals. This is molecular, but the prefixes kind of give away that it's molecular anyway. So N2, dinitrogen, tetras 4, oxide. Ammonium sulfite, here there's no prefixes, so it could just be molecular, right? Because maybe it's just a molecular with no, they're both 1, but the fact that it's ammonium, which I recognize as NH4+, I need to know that, and sulfite, which is SO3 2-, I got to balance these charges. So it'll take 2 NH4+, so my formula is NH4 2 SO3. That's ammonium sulfite. Hydrofluoric acid, okay, it's a binary acid with fluorine. Fluorine is -1, so it'll take 1 H+ to go with that, so it's just HF. Lead 4 nitrate, so lead's a metal, +4 in this case. Nitrate is -1, so I say, okay, I'm going to need 4 nitrates to balance, so PbNO3, 4. Phosphoric acid, it's not binary. Phosphoric is from phosphate, PO4 3-, so it'll take 3 H+ to neutralize that, so it's H3PO4. And then lastly, tetraphosphorus, again, this is molecular, the prefixes give it away. Tetra for non-sulfide, non is 9, so sulfur 9. And so I think it's a little easier to come up with the formulas. You'll be less likely to be confused because usually the names of the formulas give away what kind of substance it is. Like you see the word acid, you see prefixes that give away it's molecular. Usually the other ones are the trickier ones, but nevertheless, you know, take the quizzes liberally until you get a hang of it, and but that's generally the approach. So until next time, I am Derek Genova. Have a delightful day.